A asterisk search. Take a graph like showing on the screen. S is a root node and it's also called as initial state. From S to A B and A to B C. B to D, C to D G, D to G, G is a goal node. In the side of a graph we see a table. In that table, every passing nodes from root node S. They considered passing values. They represents to show like h of n. Then fulfill the values in these table from each and every passing nodes. Procedure. S says to a then seen on the screen there is a formula to solve these A asterisk search. S goes to a then f of n is equal to g of n plus h of n. From the graph and table, S is equal to 1. In h of n A is equal to 3. Now 1 plus 3 equals 4. Then in the same way from root node S will be passed to the G, take same way to solve. Like S goes to G, G is equal to f of n is equal to 10 plus 0 equals 10. Then we aim to see now root node S will be completed to solve passing nodes A and G. In the same way now, S goes to A and B. S goes to A and C, S goes to A, C goes to D, S goes to A, C goes to G. From same formula we have to solve like first solvable way, that's it. Then after completion for these the cost is 6. Cost is equal to 6 to the reach the goal node. A asterisk search is a popular algorithm in artificial intelligence used for finding the shortest path from a starting node to a goal node in a graph. It combines the advantages of both Dijkstra's algorithm and greedy best first search by using a heuristic to guide its search. The heuristic helps A asterisk to prioritize nodes that are likely to lead to the goal while also considering the cost of reaching each node from the starting node. The advantages of A asterisk search algorithm include 1. Completeness. A asterisk is guaranteed to find a solution if one exists, provided that the heuristic function is admissible, never overestimates the cost to reach the goal, and the graph does not have infinite branches. 2. Optimality. When the heuristic function is admissible, A asterisk guarantees to find the optimal solution, meaning it finds the shortest path from the start node to the goal node. 3. Efficiency. A asterisk is generally more efficient. Procedure to do solve greedy best first search. One disadvantage of A asterisk search is 1. Memory intensive. A asterisk can be memory intensive, especially in large graphs or when the heuristic function is not well designed. It needs to store and manage information about all nodes that have been visited or are pending exploration, which can lead to high memory usage, particularly in scenarios with many possible paths. A asterisk search algorithm finds applications in various fields, including 1. Pathfinding in games. A asterisk is commonly used in video games to find optimal paths for characters or objects to navigate through a game world, considering obstacles and terrain features. 2. Robotics. It is used in robotics for path planning of robots in dynamic environments, such as navigating through cluttered spaces or finding efficient routes in warehouse or manufacturing facilities. 3. Network routing. A asterisk is applied in network routing protocols to find the shortest path between nodes in communication networks, such as the internet or transportation networks. 4. Natural language processing. A asterisk can be used in natural language processing tasks, such as parsing and semantic analysis, to find the most likely syntactic or semantic structures given input text. 5. Artificial intelligence. A asterisk is a fundamental component of various AI systems, including planning and scheduling systems, where finding optimal paths or sequences of actions is crucial. 6. GIS. Geographic Information Systems (A*) is employed in GIS applications for route planning, location-based services, and spatial analysis, helping users find optimal routes between geographic locations.